You know, that glass of water on your desk, the rain falling outside, the clouds way up in the sky, they are all part of the same single ancient story. So today, we're going to follow that story. We're talking about the epic, endless journey of water across our planet. Let's trace the path of a single drop. It seems like such a simple question, right? But the answer is, well, it's pretty amazing. That single drop of rain, a week ago, it could have been floating in the Pacific Ocean. A few centuries ago, it might have been locked away in a glacier. And just yesterday, it could have been inside a leaf on a tree. You see, every drop is a tiny part of this massive, planet-wide system. It's always moving, always changing form, and constantly recycling our most precious resource. So let's follow its journey, starting from the ground up. Okay, so our story begins with what you could call the Great Escape. This is the first leg of the journey, where water actually defies gravity and makes its way from the Earth's surface all the way up into the atmosphere. Now, the main engine driving this whole ascent is, of course, the sun. It shines down, heats up the water in oceans, lakes, and rivers, and gives those water molecules just enough energy to break free and rise up as an invisible gas we call water vapor. And get this, a whopping 86% of all the water vapor in our atmosphere starts its journey in the oceans. But it's not just big bodies of water. Plants are actually huge players here too. See, while evaporation is a physical process, plants do something biological called transpiration. They soak up water from the soil through their roots, and then they release it as vapor from tiny little pores in their leaves. A single large tree can release hundreds of liters of water into the air every single day. And then there's this really cool express route called sublimation. This happens in super cold, dry, and windy places. Think the top of the Himalayas. Here, ice and snow can turn directly into vapor, completely skipping the liquid melting phase. It's like watching a ghost just disappear right into the air. So we've got all of this invisible water vapor rising up and floating around in the atmosphere. The next stage of its journey is all about becoming visible, about grouping together to form the very clouds we see almost every day. This amazing transformation is called condensation, and really it's just evaporation in reverse. As that warm, moist air rises higher and higher, it starts to cool down. And the thing about cold air is it just can't hold as much water vapor as warm air can. So all that extra vapor has to go somewhere, but it needs something to cling to. It starts to latch onto microscopic particles that are already floating around up there. We're talking tiny specks of dust, salt from the ocean, even smoke. The vapor condenses around them, turning back into tiny liquid droplets. And when billions and billions of these droplets get together, poof, a cloud is born. Now I want you to try and wrap your head around the weight we're talking about here. A single, ordinary cumulus cloud, one of those puffy, white cotton ball clouds you see on a nice day, can hold over 1 million tons of water. That is literally heavier than hundreds of elephants just floating over your head. It's a great question, right? How does something that heavy stay up there? Well, the secret is that all that immense weight is spread out across billions and billions of incredibly tiny water droplets. They are so small and so light that even pretty weak air currents rising from the ground are enough to keep them suspended in the air. But what goes up must come down. They can't stay floating up there forever. Eventually, that water has to make its way back to us. And this is really the climax of its journey in the sky, the long fall home. This return trip has a name we all know, precipitation. What's happening inside the cloud is that those tiny droplets are constantly bumping into each other and merging, growing bigger and bigger. Eventually, they get so heavy that the rising air currents can't hold them up anymore, and gravity simply takes over. And that journey home can look very different depending on the temperature up there. If it's warm enough, we get rain. If that water vapor freezes into delicate little crystals way up high, we get snow. If raindrops fall through a layer of freezing air on their way down, we get sleet. And in really powerful thunderstorms, you can get those big, damaging balls of ice we call hail. Okay, so the water made it back to the ground, but its journey is far from over. In fact, the moment it lands, it immediately faces a choice, a fork in the road that decides where it goes next. So the water has two main options. Is it going to soak down into the ground? That's a process called infiltration. It's usually slower, and it's what recharges our vital groundwater. Or is it going to become surface runoff, flowing faster across the land into rivers and streams, sometimes causing things like erosion and floods? And which path it takes depends on everything from the type of soil to just how hard it's raining. Now, if the water takes that underground path, it starts a really slow, deep journey called percolation. It trickles down through all the layers of soil and rock, which acts like a giant natural filter, and eventually it replenishes these huge underground reservoirs called aquifers. This is a very patient process. It can take days, or in some cases, even centuries. All right, so we've followed this single drop of water up into the sky, across the atmosphere, back down to Earth, and through the ground. But let's zoom out. Why is this huge, complex journey so incredibly important for all of us? First, just think about this. An unbelievable 97% of all the water on Earth is salty. Only 3% is fresh. The water cycle is basically our planet's giant natural desalination plant. When water evaporates from the ocean, it leaves all the salt behind, and that's what creates the tiny sliver of fresh water that all life on land, including us, absolutely needs to survive. And its importance just keeps going. This cycle acts as a global climate regulator, moving heat all around the planet. It's the foundation for all of our agriculture and food. It's what determines where forests can grow and where deserts will form. To put it simply, without this constant circulation of water, life as we know it would be completely impossible. This quote really gets to the heart of it all. The water in your glass today might have been rain in the Amazon rainforest last year. It could have been part of an Antarctic glacier 1,000 years ago. It really is one single shared global system. And that leaves us with a final, really important thought. If it's all one connected system, then our actions, how we use water, how we manage our land, how we build our cities, they don't just have a local impact. They send ripples through this entire great water journey, affecting the cycle absolutely everywhere.